There's a lot of talk right now about beyond just carbon, which I think is really valid. Carbon myopia is a real thing. But on the flip side, carbon is the most mature ecological benefit asset class that exists. And so there are some useful lessons that we can take away from the 30 years of history that have gone into carbon markets. And I want to communicate some of those ideas to you now. So we're seeing this Cambrian explosion of different credit classes coming online. You've got everything from plastic credits to biodiversity conservation. Land stewardship is very exciting. And the trouble is that if we're not careful, we're going to end up in a zoo where we've got hundreds, maybe thousands of different credit classes. And the buyers who are going to be funding these projects are going to have very little context to decide, what makes a good project? How do I even compare two projects if they're using totally different credit classes? So there's a need for some balance to be struck. And I want to make an analogy here with another balance that we often find ourselves confronted in ecological benefit markets, which is this balance between liquidity and fungibility. So you're probably pretty intuitive. On the left-hand side of with the least fungible assets, you have things like real estate or fine art. A Picasso is a one of one. There's only going to be one of that particular painting. And so there's an inherent limit to the amount of liquidity that painting can have because there's only one of them. And so you can't really do comparable pricing or have multiple assets for sale at different prices. On the other hand, you have something like fiat currency or sovereign debt, which are some of the most liquid instruments in the world because there are literally billions or trillions of identical units that can be priced accordingly. And in the middle, you have assets like commodities or NFT profile picture collections that have some mix, right? They have tens of thousands, hundreds of thousands, maybe up to billions. And carbon credits fit squarely in the middle. And I'm going to argue that there's a similar trade-off for other ecological benefits, a sort of corollary trade-off. And so the most important thing I want to emphasize here is that a given carbon credit from a certain project will be fungible with, say, 100,000 or maybe a few million carbon credits issued by the same project, right, within the same year, the same vintage. And those credits are fundamentally identical. But there might be another project that uses the same methodology, but in a different country. They might even issue credits in the same year. And those credits are semi-fungible. They're comparable, but they're not necessarily identical. And so there's a balance to be struck here. And there's a corollary balance, in my view, between standardizing along one dimension, like carbon, in the most extreme case, which would lead to carbon myopia, and sort of having a zoo where you've got thousands of millions of different projects. Every project is a unique, beautiful snowflake, and they can't be compared with any other project. So I don't think either of those extremes are desirable. There's some middle point we need to come to where we have a reasonable number of dimensions along which to assess ecological benefit that is at least comprehensible to humans and allows for liquidity at a reasonable level. So there are a couple frameworks out there already for thinking about ecological impact. You've probably heard of Sustainable Development Goals from the UN. There's 17 of them. You may have also heard about planetary boundaries. Alan mentioned that during his opening remarks. And these are both really interesting and largely academic and historical frameworks for thinking about impact and sustainability. They're fairly complex. And I don't know about you, I always have trouble remembering all 17 of the SDGs. And some of them are fairly abstract, right? Like partnerships for the goals is, I don't know how you're going to quantify that. I don't know what an asset that supports partnerships for the goals is going to look like. And so I think they're a little too high level. I do think the planetary boundaries is more along the lines I have in mind. So there is this other group that's working on something called the Ecological Benefits Framework. And the basic idea is that, coming up with a smaller dimensional set of factors that will be able to comprehensively address all sustainability goals. So that's still an ongoing activator. I'm a member of it. It's being run by this group called Lexicon. And we're hoping that, in a few months, we're going to have some results to report out to the community. If you want to get involved in the EBF, let me know. I'm happy to connect you with them. So I want to talk a little bit now about carbon markets and tie in some of these ideas I've been talking about, high-level concepts around liquidity and fungibility into the realities of how this market operates today. So this is a very simplified structure, but basically you have a sort of three-part market with a registry serving as this sort of mediator. So the three bodies would be the buyer, the end user who wants to use the carbon credit to make a sustainability claim. You've got the project developer who's going to be on the ground implementing, and then you have a verification and validation body that's going to check the work of the project developer and make sure they follow the methodology accordingly. Now, the key thing I want to point out here is there's only one arrow here that's actually representing the flow of money, like financial capital, and that's the one where the buyers are supporting the project developers by buying credits and retiring them. Everything else is actually a data flow. Right, the project developer is registering, they're reporting data about where they're developing and what methodology they're using. The VVB is going to assess and collect data about the project and then report that data back to the registry. So ultimately, carbon credits and other environmental assets, they derive their benefit from, or they derive their value from data. Fundamentally, they are made of data in a certain sense, even though the actual value is created by the people on the ground, obviously. It's the data about that activity that gives the digital asset its value. So I just want to give a couple examples of the type of data that I'm talking about so you have some grounding. So this is an example project page from the Vera registry. You can see a few pieces of important information here. You've got the project name, the location, the methodology that they're using, a bunch of other details. And there's also some PDFs down at the bottom. That's where all the good stuff is. Okay, it's mostly buried in the project documents. So that's an example of the type of data we're talking about. And then there's also the retirement and issuance activity. So this is more like the database of individual credits that are being issued and used. And so these are the two big types of data you're going to find when you talk about carbon credits: project data, registry data. And there's been some efforts to standardize this stuff. So there's a group called the Carbon Token Standard Working Group that I'm a member of. And one of the members there, Adam Spears from Toucan Protocol, put together this Rosetta Stone. It's sort of like a translation matrix for different approaches that have been taken to modeling carbon data. And sort of the answer is we haven't figured it out yet. There's a bunch of different frameworks. They're mostly intercompatible, like mostly you can translate between them, although there are a few sort of complex fields that are more difficult to translate. Meanwhile, you have this massive, rapidly evolving space of voluntary carbon market with hundreds of different organizations addressing different aspects. I don't want you to get lost in this. I'm mostly just trying to say we've got a huge issue with data being very fragmented and incompatible with each other. And meanwhile, you've got hundreds of people going and building stuff on top of that fragmented ecosystem. So it's sort of not necessarily a recipe for disaster, but let's just say I'm concerned about the data fragmentation issue. So what are some of the virtues that we might hope to gain by adopting an open data standard or developing an open data standard within our community? So obviously verifiability is a huge thing. That's what I was just talking about. Ultimately, if you don't trust that the claims being made by the project are verified and legitimate, then you're not going to value that asset very highly. Secondly, transparency. It's a lot easier to go in and look at a standardized set of data, especially if you want to compare across the registries and say compare the data associated with a Vera project with the data associated with a gold standard or eco registry project. Having a data standard will make that comparison a lot easier. And then finally, and most relevant for me personally, I'm an engineer, we're building products. I want to be able to integrate a wide variety of different credit classes from different registries without having to go and build a bunch of really specific logic just to handle the fact that that registry uses a different data model. So it would help a lot for organizations like mine. So there is a group right now called the Climate Action Data Trust that is trying to develop this type of standard. Let's just say it's been going on for a while. It was originally started by the World Bank under something called the Climate Warehouse, and they promise a lot. They're really tying together both UN, Article 6 agreement goals with voluntary carbon market goals, and trying to build a comprehensive system that models basically the entire carbon markets. And let's just say that they're promising a lot. It remains to be seen yet whether they'll be able to deliver. I'm very interested in engaging with the Climate Action Data Trust. We've applied to be a member of their user forum. And so we'll see how that emerges. But the key thing I want to emphasize here is they have put together a provisional data model. As you can see, it's quite complex. But this is supposed to be what all the registries will be transforming their specific format into to inject that into the Climate Action Data Trust in a standardized format. Meanwhile, that's all happening. Been going on for years. I'm a little, let's just say I'm not optimistic about the timeline for getting access to that data, but it's moving. Meanwhile, builders like KlimaDAO, we're trying to build products. We want to ship stuff and get value, flowing to these project developers and improve the user experience for buyers of carbon credits and other ecological assets eventually. So we built this new product called Carbon Mark, and one of the things we needed for it was that project data. So you see here, this is like a project detail page. This is basically most of the information from that Vera project detail page, but we're showing it in an interface where the user can actually go buy that credit. And we needed to get that data from the registry, load it up into a system where our application could then read it. And so, we basically built a custom system because like Climate Action Data Trust isn't online right now. There aren't open data standards already existing for this data. So we basically, I wrote a Python script. It grabs the data from the Vera registry, transforms it, cleans it up a little bit, and then dumps it into a CMS, basically like a private database that we run that powers our application. This is great for phase one. It's not really in line with our ethos. So we're moving toward a phase two where we use some more distributed systems. For instance, we're working with Filecoin Green Team to develop a pipeline that will extract the data from the Vera registry and other registries and put that data into CO2.storage, which is an open public data storage format running on IPFS. that's sort of the next phase. But you might notice here, like, we've just replaced the Python script with like a pipeline that's going to run automatically. That's great, but like we still have to write that code. And the real like game changer would be what the Climate Action Data Trust offers, which is that the registries themselves will write these scripts, standardize their data into an accepted format, and upload it into the Climate Action Data Trust data storage system. And then, this is a bit of a question mark because we haven't gotten all the details about how this is going to work, but we could then potentially export that data from Climate Action Data Trust in the standard format, load it up into the CO2.storage, where we've already built the integration in phase 2 to read the data from CO2.storage. And that avoids us having to go integrate directly with Climate Action Data Trust, which seems like it might be a little complicated. And yeah, sort of a nice way for us as a builder to avoid having to reinvent the wheel every time you want to add a new registry. Because that's basically the situation we're in with phase 1 and phase 2 is we're going to have to go do a bunch of work for each new registry that we add into the system. And a data standard would help us avoid a lot of that duplicate effort. So some key takeaways here, beyond just carbon could easily lead to a credit zoo if we're not careful. The EBF activator is this group trying to strike a balance, and there's some other frameworks like the planetary boundaries that may be useful here. Generally, ecological benefit assets like carbon credits, they get their value from data, ultimately. And so data is really important to attest to the value and integrity of those assets. Carbon credit data, as an example, is super fragmented, even though it's been around for 30 years. And some standardization, like what Climate Action Data Trust is trying to do, will definitely help the situation. So yeah, if you're interested in the EBF or you want to get in touch about any of the stuff I've talked about, please feel free to reach out. Otherwise, I think we have some time for questions.
Any questions? Yes.
Thanks a lot for the great talk. I think one of the problems which I'm curious about is if you look at Vera and also the other registries, the data obviously is transparent, but it's kind of a pseudo-transparency because they are locked in these PDF documents that are not machine readable, right? And actually, if you look at all these documents from Vera, that's not a lot of data. I think it's roughly 30 gigabytes. That the $2 billion carbon marketplace currently runs on. So it's less data than, I don't know, a wedding picture collection from some wedding. It's not a lot of data, but it's hard to access and read these PDF documents. And I think this is actually the main issue that, like, well, the data is there, it's apparently transparent, but it's not machine readable. So how would any of this try to approach this problem?
Yeah, so I've been focusing in this talk, it's a very good point. I've been focusing in this talk mostly on the structured data that exists already within the registries and just trying to bring that structured data together in a standard format. But you're very right. A lot of the data is buried in PDFs. So I would separate this into like a, how do we get better data and transparency on existing projects, to how do we build new systems that avoid locking up all this really valuable data in PDFs. So I know like lots of people here are working on that second point, so I'll address the how do we get better data on the existing projects. The good news is we have these really powerful AI and machine learning models that have recently come to public attention, and so there is some excitement and interest in using things like GPT to make sense of or process these project documents and turn them into something more useful. The reality is if you spend some time reading these things, a lot of it's pretty boilerplate. Like it's kind of generic, just like this is how you set up the methodology. Here's the data we're going to have to collect about the project to verify that we implemented the methodology properly. So I think there's a signal to noise thing where you need to basically train the model, fine tune the model to understand what is relevant about a carbon project. Because right now, the generic model, say if you just take ChatGPT and you're like, hey, here's a project description document. Can you tell me what's important? Tell me if this is a good project. People are already trying to do this. And let's just say I'm not super optimistic it's going to work very well unless you have a really well curated training set that you fine tune the model on. And you say, here's a dozen projects that I've looked through their PDDs, I've assessed, here's the important details. Go and look at 1,000 PDDs, pull out those same details for me. That, I think, is a really promising approach, but I would be very careful about blindly applying the large language models to something like this because they're not trained specifically on carbon projects. They're trained on the entire internet. So unless you fine tune it, I think it's going to be hard, but that's a potential really interesting idea.
Hey, Doug Miller, Clean Energy Buyers Institute and Zero Labs. So quick question, who are the buyers you're targeting and what problems are you solving for them?
Yeah, so ultimately what we aim to do at ClimateDAO is to make it much easier and simpler for any buyer to access this market. I will say that to date, our buyers have traditionally been non-traditional buyers because the traditional buyers are large corporations. They don't even know how to interact with the blockchain, let alone be comfortable buying and retiring carbon credits on it. Though we are sort of working in that direction and trying to set up some solutions that'll make it easier for them to come to the table. But historically, a lot of the buyers using the on-chain credits that we provide have been things like Web3 protocols, small off-chain businesses that are otherwise cut out of the traditional market, as well as individuals who just want to offset their personal emissions. In terms of the problems that we're trying to solve, I mean, there's really, I think it about boils down to three that exist in the traditional over-the-counter market. One is price discovery. It's just really hard to tell what this asset is actually worth if the only way to find out is by calling someone on the phone and asking for a quote. Two is the transparency, just being able to tell who has bought and sold this particular credit in the past. And third is access. If you call a broker and you're buying less than $100,000 worth of credits, they're just going to hang up the phone. They don't care. And then if you go to a retailer and you're like an individual buying, half a ton or a couple tons, they're just going to charge you crazy markups, and you're going to have no idea, how much of the money you're giving them is actually making it to the project. Yeah, does that answer the question? Yeah.
Okay, this is our last question.
Hi. So you talked a lot about the data standard for carbon, and because blockchain space is so so restricted, all this kind of stuff is built for a specific use case. But what kind of thoughts do you have about how I'm sure other people in DeFi are working on other data standards? Will probably on a different platform for credit data, counterparty data, finance stuff. How's it all going to kind of come together, since it's not like it all sits in the same place?
Yeah, so there's a couple things there. You're right, there are fundamentally different data systems, and ultimately there has to be integration between those different systems. Like in our case, we have off-chain registry data that we need to combine with on-chain transactional data to get, say, our carbon dashboard and show like what types of credits people have been buying recently. So yeah, there's definitely some engineering work there. In terms of like standardization and data systems from other parts of blockchain technology, one of the systems that we build on top of is called the Graph Network, which basically provides a programming language effectively to model blockchain data and turn it into a more meaningful data model. So we use that a lot, and we think that tools like that for modeling blockchain data in a more human understandable way are really powerful and should be applied. We're using them in carbon markets.